Hi, and welcome to our video 3C, where we're going over our Chapter 3 review. I got a Kit Kat, though, so I wanted to show you. I know I showed you him once already. All right, so we're describing relationships in this. So again, read all of your content, and piggies are awesome. Information at the beginning, timer, cue. Here comes the original question. Moving on to A, moving on to B, moving on to C, moving on to D. All right, here come the solutions. So A says briefly describe the association shown in the scatter plot. And make sure you read through the context so you understand what we're talking about here. But if I notice, hey, if I draw a line, it looks like I could draw a pretty straight line. If I notice it, the dots are pretty close to the line, the linear line that I've drawn, right? They're kind of clustered around them, and it's in a positive direction. So guess what? I have a fairly strong positive linear relationship between sugar and freshness. That was super easy, wasn't it? Okay. Need more practice on positive and negative linear associations? Here's the con. So, getting into LSRLs, our least square regression lines, the equation of our LSRL is y hat is equal to 180.8 plus 15.8x. So interpret the slope of the line in context, but just to go a little further, I'm going to go ahead and interpret both parts. So here is my entire LSRL. Red y hat, A value is our y-intercept, and B value is our slope. So in this one, 180.8 is our A value, our y-intercept. And what does it mean in context? At the time of purchase, the flowers would live for approximately 180.8 hours. Or if you put no sugar in, great, your flower is going to live for 180.8 hours. The B value, or the slope, is actually 15.8 hours per 1 tablespoon of sugar, right? Because it's change in y over change in x. So that means for every tablespoon of sugar added to the vase of water, the flower's lifespan increases by 15.8 hours. Cool. So now we've done it. We've interpreted the slope of the line in context of the study. So let's write that out. For each increase of 1 tablespoon of sugar, the predicted freshness increases by 15.8 hours. Boom. Dunzo. Need some more help interpreting slope or y-intercepts? Here's a con activity for you. Alrighty, calculate and interpret the residual for the flour that had 2 tablespoons of sugar and looked fresh for 204 hours. So this one's the more in-depth question here. So now we're going to have to calculate, first of all, what is the y hat value at 2 tablespoons of sugar, and then calculate that residual where we take the y minus y hat, okay? Remember, advanced placement, actual minus predicted. Okay, so here's our y hat from the previous question B, and I went ahead and calculated y hat at 2, so I plugged in my 2, and I got 212.2 hours. Great, so there's my y hat. But now I still have to calculate the residual. So I want to calculate the formula y minus y hat, or AP advanced placement, actual minus predicted. So I take my actual value minus my predicted. They gave me the actual in the question. They said for 204 hours. So I got negative 8.4 hours is my residual at this point of 2 tablespoons. And what does that mean? Well, it means that the carnation stayed fresh for 8.4 hours less than the expected amount on the sugar it received. So they actually expected it to last longer, which we saw because it was 212.4 hours. Cool. Need more help with our residuals? You can go here. And finally, suppose that another group of students conducted a similar experiment using 12 flowers, but included different varieties in addition to carnation, so they've got more than one type of flower. Would you expect the value of R squared for the second group's data to be greater than, less than, or about the same as the value of R squared for the first group's data? Explain. Well, first and foremost, what is R squared? That's a big question we got to be asking ourselves. We were like, okay, R residuals, kind of remembering and recalling. But let's go ahead and jump back in. What is R squared? The biggest thing I want you to take away from this slide is that the higher the R squared, the better the model fits your data. You can pause at this point and read through the slide, but I'm going to move forward. So would I expect the value of r squared, so how close my data fits the line, for the second group's data to be greater or less than whatever. So if I've got an original experiment, we're dealing with carnations, my R squared value is pretty good, right? It was fairly strong. All my points were pretty close to that LSRL line. But that was line. LSRL. We're good. Okay. Um, but the second group has lots of different kinds of flowers. So technically you're comparing different species and their different freshnesses. Is that really a good comparison? Are those associations going to be as strong as the one where you're just focusing on a single species? Probably not, right? So my R squared value, would it go up or down? Would my R squared, we're saying that it's going to be less strong, so a looser association. So my R squared value is actually going to decrease. It's not going to be as close. So, because other flowers will probably stay fresh for a longer or shorter period than carnations, this will be an additional source of unaccounted for variability in freshness. Because there will be less variation in freshness that's accounted for, the R squared value itself will decrease. And that's all I got for you guys. So here is your con for this. It's a unit test. It does go over a couple other topics from this chapter. And let's talk about the assignment. At this point, you can skim through the PDF for answers to the odd questions from the chapter review. You can also email me for the even answers, or you can jump right into your assignment. Make sure to pick one of the following three options. Of course, you can do more for additional practice, and I will grade it. Your best option is option 2. Solve one FRQ question from the practice test. Or you could solve 3 multiple choice questions. Make sure you show me your work. No work with a multiple choice. I cannot really call it complete. Send screenshots of your con practices and your final screen. So make sure you show me every time you answer when you see whether you got it right or wrong, and then the final screen. It's a lot of images, so make sure you put it in one document. And that's all I got for you guys. So see you in the next video.